Can you see how rolling a circle of radius 1 from left to right would result in the x-axis shown below? As this circle rolls, this x over 2 point would land right there, this pi point would land right over there, and so on. It would keep going. If you are connected to the internet, click on the hyperlink below for a Desmos simulation of the circumference unrolling. Then skip to slide 151. Alright, so the circle is rolling. The first point has hit down at pi over 4. As we keep rolling, pi over 2 has landed right there. The next point would be 3 pi over 4, and then pi. And finally, when the circle finally has rolled one complete time, we end at 2 pi. The circumference of the unit circle is 2 pi, which is why, when unrolled, the values on the x-axis will go from 0 to 2 pi. If you're connected to the internet, click on the hyperlink below for a Desmos simulation of the circumference unrolling. Here are the colored line segments we drew in the unit circle for the value of sine x for each x in quadrant 1. Let's take these line segments and organize them along the unrolled circumference. The result is a new graph with the same information, but the information is presented in a different way. Alright, so we're going to begin with this point here on the unit circle, and this length of green line we're just going to draw here at the pi over 12 point, because this point here is at pi over 12. So we're going to draw that right there on our new axis. Now here at pi over 6, we have a line that's this long. So we're going to draw that same line right here at pi over 6 on our new axis down here. This is our next point, and that is at pi over 4 on our circle. So we're going to take that red line and redraw it at pi over 4 on our axis. Now we have the point at pi over 3. And so we have this purple line. We're going to redraw that purple line over here at pi over 3. Next we have 5 pi over 12 right up here on the circle. So we're going to take that orange line, draw it right over here at 5 pi over 12 on our axis. And finally we've reached pi over 2 on our unit circle with the maximum value for sine, which is 1. And we're going to redraw that black line right over here at pi over 2. The values connected together, they fit to create a curve called sine x. Complete the sine values, the vertical segments, for quadrant 2 before going to the next slide. Okay, so I'm going to paste in our unit circle here. So we can see that for 2 pi over 3, it's going to have the same sine value as it did at pi over 3. So at pi over 3, we're right here. So we're going to draw that same point over here at 2 pi over 3. And then we can draw the line, and we'll color it purple, just like that. All right, the next point is going to be at pi over 4. And pi over 4 has the same sine value as 3 pi over 4, which actually isn't even written in here, but it's halfway between these two. So right here we're going to have pi over 4, and the value is going to be right on that red dashed line, right there, and we're going to draw a red line right there. Okay, our next point is going to be at pi over 6. Pi over 6 has the same sine value as 5 pi over 6. And it's going to be right at that blue dashed line right there. And I'm going to draw a blue line that connects it. That'll do. All right. And then finally, we have this point here. It doesn't have a dashed line, but it's pretty close. Pi over 12 has the same value as 11 pi over 12, which also isn't here, but 1.5. It's about there. That's about 11 pi over 12. And it's going to be just over that line, like that. Now you can connect these lines with a curve, like that. The red curve here is 1/2 of the sine wave. It represents the information that was in quadrants 1 and 2 from the unit circle.